When we talk about analog to digital converter, we talk about a box, something like this, and we have analog input, and the output is digital. Since it is digital, it may have number of bits. So, this is digital output. Now, first of all, we try to understand what analog to digital converter or ADC in general is. So, first thing is what is A to D converter? It is a black box for us right now, which takes analog input and digital output. Analog input means any input, any electrical signal which can take continuous values like temperature or pressure or any continuous value signal, and digital output will have discrete values. It will be in the form of ones and zeros. Everybody getting this point? Now, then we try to understand why do we require this? Why do we require this? So, many of the analog signals are available from the various sensors like temperature or pressure. Many real life quantities are available in analog form. So, but computer, as we know, cannot directly handle analog signals. It has to be converted into digital output. So, if you want to do some processing on say temperature value, averaging, pressure, its averaging, or whatever computation we would like to do, it will all happen in digital domain. So, we need to convert analog to digital somehow. Now, what is that somehow we are going to learn today, correct. So, when we think of A to D converter, we first of all think of various types. What are the various types? Or before that, we can think of what are the various important things we need to know about A to D converter. Number one is that number of bits used for ADC, that is A to D conversion. Now, this in fact is called as a resolution of ADC. It means what? Some A to D converters may have 8-bit resolution, some may have 16-bit resolution, some may have 24-bit resolution, and so on. So, what does it mean for us? Why do we think of this? Suppose we have 8-bit resolution, then what will happen is that the output, suppose if I try to plot say input versus output of A to D converter, for 0 input the output digital will be 0 0 0 0, all zeros. Now, if we consider 8-bit A to D converter, the output will be 8 bits. So, all 8 bits will be 0 0. So, 0 0 0 0 0 0 0 0, this is the output for 8-bit A to D converter if input is 0 volt. If the input is maximum 5 volt, the output will be 1 1 1 1 1 1 1 1 full scale value, and if it is in between, the digital value will also be in between, some combination of ones and zeros which is in between 0 0 0 0 up to 1 1 1 1. So, actually it will take discrete values like this, because the input is continuous, but the output cannot be continuous. Output will take either 0 0 0, this is this value, and if you consider the next value, immediately next value, it can be 0 0 0 0 0 0 0 1, which will be this. Next value will be this, which can be 0 0 1 0, and like that. So, we have discrete values at the output. Now, how many steps will be there in such case depends on how many bits we use. For example, if we use 8-bit ADC, suppose we have 8-bit A to D converter, then we can have values from right from 0 0 up to all ones. So, we have 256 levels. Now, these levels correspond to, there will be some minimum value or maximum value. So, I have written here, so I will rewrite it once again. 0 volt corresponds to 0 0, 0 0 0 0 0 0. So, this corresponds to 0 0 hexadecimal, and 5 volt will correspond to 0 0 0 0, sorry, 1 1 1 1 1 1 1 1, and this is FFH, FF hexadecimal. So, 5 volt corresponds to FF, and if you write in decimal, it will be 0 and it will be 255, correct. So, 5 volts corresponds to 255. We will have to find out what 1 corresponds to. 1 corresponds to what electrical level? 1 corresponds to what electrical level? So, we have to find out how much is this. It will be 5000 millivolt, that is 5 volt divided by 255. So, this comes out to be nearly 20 millivolts. Is this fine? 20 millivolts. It means if the input is less than 20 millivolt, there won't be any change in the output. If we have input, for example, again I draw the graph and I increase the zooming value and so on. So, this is input. The input may be anything because it is continuous, and it can go from 0 up to 5 volt somewhere here. It is out of the range of the scale, and the output will be digital in the form of values like zeros and ones. So, the first value, first combination here, maybe this combination corresponds to say 1, this 1, and we have to find out the corresponding electrical level, say this electrical level. Now, this electrical level will be 20 millivolt, correct. If it goes to 21 millivolt, 19 millivolt or 15 millivolt, there won't be change in the output. Unless and until it goes beyond 20 millivolt, it won't change. So, if the input changes by a small amount, the output is not going to change immediately. It has to change by at least 20 millivolts. So, this is what is called as the resolution. Resolution in the form of analog, and in the form of digital, it becomes the number of levels. This is the resolution. If you do the same thing for 16-bit A to D converter, then 5 volt is the analog input, it means 5000 millivolt divided by 2 to the power 16, because 2 to the power 16 are the levels. So, it becomes 5000 divided by 65,000, 5, 2 raised to 15. So, whatever the value is, 65,000, all combinations we can have. Nearly I will write 64K in general, and this comes out to be how much? Can somebody compute this, or maybe I compute this? So, 5000 divided by maybe 64K. So, 0.078 millivolts, 0.07 millivolt. So, it comes out to be how much? 70 microvolts. So, if the input changes nearly by 70 microvolt, the output can change. So, that way 16-bit ADC is better as compared with 8-bit ADC.